Okay, so we saw the picture of a neuron, but let's speak about the neuron as an input-output device for a second. It will be too early, but then we'll talk about the different elements and we summarize everything and it will become understood. So I want to just conceptually show you for a second how we think about the neuron today as an input-output device, and then we'll go step by step to study that. So here is a schematic description of a neuron. The blue neuron is the postsynaptic neuron, the receiving neuron. The red neurons are the presynaptic neurons that make synaptic contact to the blue neuron. So the red neuron have a synapse here with the blue neuron. This red neuron have a synapse here with the blue neuron. So many thousands of cells presynaptic to the blue cell connect to the dendritic tree of the postsynaptic cell. So imagine that you are a tree, you are the blue tree, many wires approaching you, many axons approaching you, making synaptic contact. We'll talk about synapse. And when they make synaptic contact, they locally, in the dendrite, make a little change in voltage, a little voltage change, a little potential. This is called the synaptic potential, locally. So these are all the red neurons. There is also another group of neurons, let's call it the green neurons or the magenta neurons. Many of them, I just show one of them, these also make contact to the dendritic tree of the blue neuron. But this cell is a different type of cell because instead of, and it has a synapse here, but instead of making a positive voltage, a synaptic potential that is positive, that is excitatory, like the red cells that are excitatory cells, this cell tries to inhibit the postsynaptic cell. It generates a negative current, so to speak, in order to dampen the activity of the postsynaptic cell. So you see that there are these signals here. These are the signals that we shall discuss a lot called action potentials. They carry information from the red cell into the synapse. In the synapse, there is another voltage, another potential that is called synaptic potential. From this cell here, from this cell in the dendritic tree here, and so on. And all of them together sum. The plus, the excitatory, and the minus, the inhibitory, all sum over the dendritic tree. And eventually, the postsynaptic cell, so to speak, decides whether he generates an output, yes or no. The output is, again, a set of action potential of spikes that we should discuss later on. So to summarize what I just said, I said that there are two types of inputs, general types of inputs to a dendritic tree. Excitatory input, coming from the, so to speak, red cells. Of course, they are not red in reality. They are red in this figure. They tend to excite the postsynaptic cell by generating locally a positive potential. So these are the excitatory cell. There is the inhibitory cell, which tries to inhibit the postsynaptic cell by generating locally a negative voltage. And the output of this cell, if there will be an output, it will look like a set of these bits, of these spikes. Tuck, 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 tuck. This will be the output of the cell, the spike output of the cell. Of course, this axon may connect, certainly connect, to another postsynaptic cell. So these are the presynaptic cell to the blue cell, and the blue cell is presynaptic to the next cell. Okay, so postsynaptic potential that are excitatory, postsynaptic potentials that are inhibitory. All this region is the input region of the cell, and this already we spoke. I told you that Cajal already thought that the dendritic tree is the input site of the cell. He didn't know that there are synapses. He did not know that there are two types of synapses, excitatory and inhibitory. But he realized that the dendritic tree is the receiving receptive part of the cell, and that the axonal tree is the output part of the cell. So this is a very general view, modern view, summarizing concept from Cajal, but now with more details, because I'm telling you to summarize that the cell is an input-output device. The input is received over the dendritic tree. The input consists of two types of synapses, of two types of inputs. The excitatory input, the excitatory synapses that tend to excite, to try to make the cell fire, and the inhibitory inputs try to dampen, to inhibit, to control the output. So this is the input, which consists two types of input, excitatory red and inhibitory magenta. And the output in the axon looks like a set of spikes, if there will be spikes. You can think about this today in a more modern way, so to speak, in a direct way. You can record today inside the brain with an electrode impaling the cell body near the axon. And you can see that this cell may generate spikes. They will look like this. So this set of spikes at the soma will flow along the axon, make connection through synapses to the postsynaptic cell. So if you want to summarize it in a different way, this is now a reconstructed cell. This is a pyramidal cell from the neocortex. You will see a lot of this cell because it's a very principal cell in the cortex. This is layer 5 pyramidal cell, the cell body, the green dendritic tree, the red axon. So you see the axon comes out from the cell body and then branches and branches. And there are all these little spots, all these varicosities. Okay? And if you record with an electrode in the axon, so if I implant electrode, small electrode into the axon, and I will try to listen to the action potential to see what is the electrical activity in the axon when the cell is active, I will hear something like that. So you now see the action potentials in the axon, all over the axon. They will propagate. We'll talk about propagation. So the axon is the output device, and this device is making this ta-ta-ta-ta-ta-ta-ta-ta-ta-ta. This is the elementary barcode, the elementary spike, the elementary bit of information. 0 or 1, each spike may exist or not. That's the very fundamental, basic building blocks of the brain.